this. Okay, good. So what we did last time was that we first randomly sorted or shuffled this list to make sure that there is no bias, there is no ordering of sampling that is going to change the behavior of the classifier. So first we created a random list in here and then sort based on this random number. And so the list was sorted, and the 3NN classifier was simply finding the 3 closest samples to the sample that we want to classify, and then to see which classes are those 3 samples, and then do the decision. So if we want to even, let me see if I have a digital pen in here. Not ready here. So in essence, webpad is in here. Start drawing. So in 3NN, if you have few samples like this, and then this one, so the new one that you have, for example, this question mark. For this question mark, I find 3 nearest neighbors, 1, 2, and 3. So these are the 3 nearest neighbors. So among these 3, I have 2 of this circle class and 1 from this sign. So the majority vote goes to the class number 0, for example, which is the circle, and the other one, which is 1. So this is the whole idea of the 3 nearest neighbor. And when it comes to 5 nearest neighbor, we measure 5 closest samples. So it would be 1 more here, and another one will be this one. So among these 5, again, majority would be with this class circle. So if we want to code, I will code this one in MATLAB as a sample. Based on this, you can work on it to turn it into any language, to Java as a practice, or C++. You can simply work with both of them and repeat what we are doing here as an exercise for yourself to create your 3NN classifier. Okay, so let's see what how we can code this. First of all, let's create an Excel file that contains, this is the test data and this is the train data. Okay, so let's create one Excel file because we want to read that file. Okay. So this is the train data. Let me save it on desktop.
This is still the data from the cancer example?
Yeah, the same example, yes. We instead of the spreadsheet that we just wanted to explain the concept, the same data we are going to use in here to code it in MATLAB. Okay.
Understood.
So 3NN, let's have AI MATLAB, then inside it 3 KNN MATLAB. This is train XLS. Okay, this is one of them. The other one would be test data. There are some missing data. You see that these question marks are missing data. Okay, so missing data is studied in pattern recognition. It's not the case that we throw out the data because one of the measurements are missing. Here, for this simplicity, I want to avoid this data. I don't want to use this data. So we will eliminate this kind of data. For that purpose, what we can do is, for example, if I sort by, I believe by this column from A to Z, then all the 3 question marks are in there, and we don't see any other question mark. Let me see. Yeah, only the 3. So I will get this data, and to here, copy this into a new spreadsheet. And again, I will save it, AI Club. Okay, this one will be test. This is the process that you will repeat if you want to code your work on where is the AI Club? Okay, here. If you want to code your work in C++ or Java, you will need the same set of the files to load those files into your program and then write the code in the same way that we are going to write in here with a little bit more details. Because in MATLAB, the good thing is that everything is based on matrices. So it is a little easier to write these kinds of codes in MATLAB because your assumption is that everything is in terms of a matrix. So it makes life easier whenever you want to code problems that are mainly matrices. But it doesn't, it's not the fact that in other languages it is going to be a hard problem. There we have vector class. For example, in C++, if you remember, we have vector class that you can easily create one-dimensional and two-dimensional vectors. So the same process can be repeated there with a little bit more lines of code. Not 10 times, perhaps 30% more number of lines.
A quick question. It's not really that related, Professor, but if you actually have matrices of a bunch of terms, can you have it the code match the different terms?
Could you elaborate a little bit more on it using this example? For example,
if you had different sources, for example, if you had multiple matrices of terms, and you had multiple sources, could you have it match the overlap of terms across those different sources?
You mean the columns are in different order? Then you need, for example, if I have 2 measurements from 2 different labs that for any reason we didn't tell them which one is the first column. For example, this is gene number 1, gene number 2, gene number 3, and the other genes. 9 genes in here, and this is the cancer type. Okay, this is the abundance, and this is the cancer type. So one lab might first measure gene 1 and then gene 2. The other lab might first measure gene 2, then gene 1. So if you have the labels here, when I copied, if you remember, when I copied, I didn't copy the headers. Okay, I only copied the numbers because I know that the 2 files are matching. But if you have it for any reason, you think that in your test data, x1 is in here and x2 is in there, then if in your Excel file you have the headers, after downloading them, after loading them into your program, you can double check to see if the headers are matching. If they don't match, then you swap some columns to make them match.
Okay, thank you.
Okay, sure. So now let's see. First, this is going to be our main program. In our main program, so the first step is loading data. Okay, and then the second step would be designing the KNN. Let's call it KNN generally. It can be 3NN or 5NN or any other number. KNN classifier. Okay, and then testing or evaluating the performance. Okay, good. So now let's first load the data. For loading data in different languages, there are different ways. In MATLAB, it is XLS read. There's a command that reads Excel file simply into, you see, XLS read the file name. Very simple. So first, let's make sure that let me save this. I would call this one main, and this is good. These sessions are good because not only you are seeing the applications and implementation of artificial intelligence and pattern recognition algorithms. If you haven't worked with MATLAB, then you get also the feeling and taste of coding in MATLAB environment, which is a little addictive if you work with matrices, because life is, I don't want to say much, but it's a little easier in MATLAB. So it's interesting to see how code can be easily implemented in MATLAB, but also remember, MATLAB is, as the name says, matrix laboratory. So it is good for exploring and learning and discovery. So it is used in the edge of science for exploring new algorithm because implementation time and complexity is much less using MATLAB. But when it comes to industrial implementation, it's not very useful because it is slow, the code is heavy. But the advantage is that you think less when you code with MATLAB because many things are ready in here. Okay, so this is going to be our main program. So XLS read, let's call it data train. XLS read, and where did I save it? Okay, I didn't want to save this function, this program in there. So let me create new, paste in here. Let me close this, and now let's save it. We want to save it on desktop in the folder that, where is the AI Club, 3NN MATLAB. Okay, now this is the main. Okay, file name is going to be, let's go to the, usually we have very good samples in here. For example, let's go here, test or train.xls. Go to our MATLAB. Okay. And the good thing with MATLAB is that, you see, you have this beautiful tooltip in here, and that's the reason some part of coding becomes much easier.
Is that the rows and the columns?
Exactly, yes.
Okay.
So whenever you load it, while you are coding, you have a feeling of what's inside your data.
So it automatically recognizes the data type as well in there, double?
Yes.
Oh,
So
awesome.
let's go and see here. You see, MATLAB has a workspace. Workspace is where the data that you load is in there. If I click on it, it is the same data. Now from the Excel file, it's in a data format that MATLAB recognizes. Okay, this is the same matrix of the train. So running that line of code, data train is now a data matrix that is read from this Excel file and has all the information that we had in there. 566 multiplied by 10 columns. Correct? And you can explore them, and even you can manually change one of them. Let's see, I made it 9. Let's not make it. Okay? So you have good exploration of the data that you are loading, and even while you are running the code, you can use the debugging tools in here to simply pause in somewhere and also check the value of the, for example, the index of a for loop or anything that you want to check. So let's now do the same for the test data. Data test. Then we will load test.xls, correct? Let's now run it. So you see, this appeared here. This one, now we have 2 matrices. First matrix is called data train. The second is called data test. Correct?
Yes.
Now let's separate the first 9 columns. We have 10 columns in here. The first 9 columns are the attributes, are the features, and the last column was the class, cancer type. Correct? So we have 2 cancer types, cancer type class 2 and cancer type class 4. So now let's separate here. What we would say is that XTR or X training is, and see how it is easy using MATLAB to avoid writing a for loop. If I want to separate 9 columns from this matrix, I need to write a for loop that goes from column number 1 to column number 9 and then create a new matrix. Okay, but in MATLAB it is easy. What we say is that if I want to separate, let's see an example here, then go there. How can I move this one? Okay, you go there. So let me show you an example. Matrix A, I want to have a matrix A which is simply 1, 2, 3 in the first row, 4, 5, 6 in the second row, and 7, 8, 9 in the third, 10, 11, and 12. Let's see this matrix. 1, 2, 3, 4, 5, 6. You see A is in here. 4 rows and 3 columns. So let's say I want to separate this row and this row from this matrix. I want to have a matrix B that is, this is the way we separate it. With comma we separate, before comma we write the rows that we want. I want to have row number 2 to row number 3.
Isn't it 1 and 2? It doesn't start from 0 then.
Yes, it doesn't start. That's a good thing. Yes, yes. You remember in C++, we started counting from 0. Here everything is from 1.
Understood.
Okay, so for the columns, I want to say I want to have all the columns. So there is no start point and no end point. You see? So row number 2 is selected. Very simple. Without any for loop. Actually, for loop is hidden inside it. So MATLAB does that for loop for you. You simply say from matrix A, I want to have row number 2 to row number 3. And which columns? I don't care. All the columns. I care actually. I need all the columns. So there is no start point and no end point. So just one column. So, or for example,
the colon there, it kind of replicates the same style as in Excel in the formula bar that we use.
I haven't used the colon in Excel.
No. What I'm saying is that using the colon, it establishes the range inside of Excel.
Yes, you're right. You are right. Whenever exactly, for example, when you say, for example, if you want to find the average, this one, and when you select this and come to here, you see this column. This is the same column. It says start.
Yes, that's exactly what I meant.
Yes, yes, correct. You're right. So now B is this one. Let's go to C. Matrix C. We want to have on the last column of this matrix, or last 2 columns. C, we can say from matrix A, I want to select last 2 columns. So I don't have any selection on the row. So I put only colon, which means start from the beginning to the end. And for the columns, I want to select 2 and 3. 2 to 3, 2 to 3. And you see, matrix B becomes the last 2 columns. So this is very good because one line of code here is equivalent sometimes to few lines of code in C++ or in Java. Okay? So here,
it's very efficient.
Very efficient. Yes, that's the reason I say this is addictive. Okay?
Right.
If you write it, it will be hard to go back to C++ for these kinds of problems. So what I say, can you read this one now? We say from data train, select how many rows? All the rows. And column 10. This is column 1 to 9. Correct?
Yes.
And let's go to XTS or test. From data train, select all the rows, column 10. And we will repeat this for sorry, this is going to be called, we will call it YTR. Y is the class. Class number is the column number 9. And it would be better if we call it TRX and training last column, Y, or class, or we can call it TRC. We use X and Y. It's like a function. X is the inputs or features, Y is the class number. We will repeat this for the test data. TS, data, test, and data test. Let's now run it. And good thing in MATLAB is that, you see, I want to run this block. By this 2 percentages, you create blocks of the code. So if you want to run a block of code, you can simply run that block without going to the next block. So you can test your code block by block. That's easier to debug instead of compiling the whole code and seeing what happens. You see, run and advance. It ran this block and went to the other block, which is empty for now. But if we add any code in here, we can run block by block, which is easy. So now let's see what happened. So we had data train 566 multiplied by 10 columns. Now TRX and TRY are the same number of rows. TRX has 9 columns instead of 10, and TRY has 1 column, which is the output, correct?
Yes.
And TSX, the same with the test data. Okay, I think we have more. Good. Let me just make sure that we don't have any participants. Okay, good. Waiting. TSX, TXY, 9 and 1. Okay, so far so good. So now we have separated. Loading data is done. Now let's see how we write functions in MATLAB. So functions are, again, easy in MATLAB. For example, function y equals my func x. This is function y equals my func x. So you can simply say y equals x squared. And then you can simply call this function, and then we will put this one in a separate file. So let's test our function. We will delete this block later. Test this simple function. So I have x equals 1, and then I say, or any a equals 1, and then we say y equals my func of a. Display, it is like cout in
C++.
C++, yes. Display y. So this my func is declared. We need to have this one in a separate file with the same name. So Control N for a new file. My func, let's save it. I will call it my func. That's very easy. Function, output, and the input in parentheses, and we write the operations in there. So now let's see. You see, output is shown. Now let's see something good. So if you want to initialize an array in MATLAB, if you remember in C++, we need the for loop, and also we need to declare the size of the array and those, let's call it hassles. But as I mentioned, when it comes to industrial programming, something that you need to make sure that it's stable and also it is running fast enough, you are going to use C++. So again, when we are talking about the advantages of using MATLAB for matrix operations, we don't talk about the disadvantage of this easier life, which is heavier code and slower code. But here we don't feel that because we are not running something for online face recognition. Okay, so we get the benefit without seeing the disadvantages. So let's see how easy it is to initialize a vector. So if I want to declare initialize a vector from -5 with the step size of 0.5 to +5, that's it. You see, start point, step, and end point. There is a for loop inside this. It's the declaration and also initialization in just one line. Okay, and in my func, I would put dot in here. I will explain it later. And this y, and let's also plot x and y. And let's see how MATLAB is good in plotting. Oh, not x and y, a and y. Let's use x. Okay, that's good. Let's use x. Isn't it good?
Yes.
So simply, we have plot x squared. And you can go and do, for example, sine, cosine, whatever. If you go here, let's make it x squared plus 2 multiplied by sine of x. Let's see what happens. Nothing much happened. Let's use smaller step size, 0.5. And also add more. You see, this one is x squared plus 2 sine x. So you can create beautiful plots, and also after creating, you can work with them. For example, you can add some data tips in here. You can work with the colors. You want to add legend, simply click on it. Or this is nice for preparing your plots for any publication, you know, like writing a white paper or a journal conference paper. It has also good tools for working with plots. And also, like the Excel, you have some tools in here as well. You see, for x and y, if you right click on it, for example, right click on y, you have some plots as well here. For example, pie chart, area, bar. Let's go to bar plot of y. That's it. Okay, simply by right click on it, right clicking on it, and area, pie, histogram. Let's go to pie chart. This is pie. Okay, so now that we know how functions work, let's so let me comment this section. Where is the comment? Control R. So we now want to create our 3NN classifier or KNN classifier. So the KNN, let's see what we need. So first of all, we need a function. We will think about the output. It will be KNN. For the KNN, we need to have any test data that we want to find its class. We need to have the XTR or TRX, TRY, and also this is the matrix, and also test sample X, and also the number, how many NNNs? Is it 3NN or KNN, 5NN? So the parameter K is also needed if we want to have a general KNN classifier. If we want to have 3NN classifier, then we can set the K to be 3, so we don't need to check for it. So the output of this is going to be class of the decision class. We assign, for example, we get a number, we compare it with our training, we find the 3 nearest neighbors, and based on the majority vote, we say, okay, this was from class circle or rectangle. So this is our function. So how we work with this?
You just pass the values because you defined the parameters there in the parentheses.
Yes, the values are passed. So there is no problem to have different names or the same names in here. So we could call this one xtr or anything, as long as inside our function we are referring to the same parameter names or matrices, that's fine. Okay, so what we need to do is that we need a for loop to go through all the train samples, and we need to find the distance. We need to find the distance between our test sample, which is a series of 9 numbers. Let's see. Let's first go here. So this is my test data, or TSX. Let's open this TSX. So I would give, for example, this one, line number 3. I will separate this line number 3, and I will give it to the 3NN classifier. So what we need to do is that we get these 9 numbers, we need to compare it with TRX, all the TRX one by one, find the distance, and then sort it, and then based on the sorted file, find the majority vote. Okay, so what we need to do, we need to find the distance. The distance, we will do the test sample with all the training data. So the distance will be a matrix. Let's first give all the distances to be zeros. So we have a zeros function in MATLAB. For example, d zeros 10 and 1, which is 10. So it creates this matrix D, 10 zeros. Okay, initialization is good because it increases the speed of the program. It's not necessary, but if you declare the size of the array, then it helps the MATLAB to not dynamically increase the size, because every time that you add a number to previous vector, then it is somehow removing the previous vector and creating a new one. So if you know the size of the matrix that you are going to fill in, then it is better to give it a size. So, and also we have size. Remember matrix, this one. Let's apply size in here, size A. Size A is here for matrix with 4 rows and 3 columns. Size A is 4, 3. If you want to get this as parameters, you can say row numbers and column numbers is size R becomes 4 and C becomes 3. So if I want to get training data number TRD num, I want to get and also the number of features, feature num equals, I can apply this size to this TRX. The first number will be the number of rows, which will be the number of data, training data, and the second will be the feature num. Okay, so after applying this, TRD num is found. So now that I know the number of my data, training data, I don't want to use the fixed numbers. For example, I could use 566, but we want to have a code that is flexible. Whenever new data comes in, it works. So we don't want to work with exact fixed numbers. So this zeros TRD num and 1, which is create a distance matrix with size number, row number TRD num and 1 columns. Now we have a distance matrix. So for now we need to start one by one. We will go to our training data, and one by one we will find the distance between these two, between our test sample that we want to find the class and our training samples. So for loop is done, I equals 1, 2, what is the end point? We will go to the TRD now. It's a for loop. Start from index 1, go one by one to the last item, which is the TR data now. And let's put end in here. End is the end of the for loop. So inside my for loop, good thing is that in MATLAB we have a norm function, I think. Yeah, norm. So let's test it. I have a vector A1, which is 1 and 2. 1 and 2. And I have another vector A2, which is 4 and 7. So the distance between these two, D A1 minus A2 would be, you see, A1 minus A2 is 1 minus 4, which becomes negative 3, and 2 minus 7, which becomes negative 5. So if I want to find the distance between two vectors, we can use the norm function. Norm function, you can simply say A1 minus A2. This is the norm. Norm is a distance. Simply, it's in there. It's the Euclidean distance. You can write it yourself as well, but it's in there, so we use it. Okay, so the distance I would be norm from my training X row number I, all the columns, minus my test sample. Let's go to our function and test it. It's not complete yet, but let's debug this code and see how it functions, designing the KNN classifier and evaluating. So let's, for example, call our KNN function. Let me copy this. And for now, let's say class is 0. Now, let's go to our main function. Let's call this TRX, we give it, TRY, we give it. Test sample, let's give the first row from the text sample. This one, from TSX. From TSX. Let's open it. This one, the first row. So if I want to give the first row from TSX, row number 1, I want to have all the columns, correct? So from TSX, I want to test row number 1 using my KNN classifier. So now let's run the code. You see this debugging? I clicked on it and it's enabled. which means the code will come in there and will stop there. Okay? Now that the code is stopped, what we do, we can go a step inside that function. Okay, let's see what was the problem. Okay, we haven't given the k. Let's make k 3 in it. For now, let's make it 3. So run the code again. The code will come and will stop in there. Step in. So now let's see how useful is the this debugging in here. So I can go 1 step, 2 steps. So if I go 1 step, class is 0, tr none. Is this correct? Is this the correct number? The number of data training?
Yes, number of rows. Yeah.
Exactly. What about feature none? Is this correct? 9.
Yeah. There are 10, I thought.
10. The last one is the class number. Okay.
Then yes, it is correct.
Yes, that's the class number. That's in here. Okay, try. The last one we have separated it. So now this we say that let's initialize distance. Okay, we want to create a vector of 0. What is the reason for this one? We say for speed of the code, because we know that we will find 566 distances. So let's create a matrix first so that the code runs faster. Okay, now my for loop starts. You see, 1 step forward. What is I number? I is 1, which means we are going to find the distance from my training row number 1 with my test sample. Let's see, distance is 0 for now. Everything is 0, but if I move forward, the first distance is found. You see, number 14 in here. If I continue this 2 times, I will have 2 distances. And if I continue this 3 times, I will have 3 distances. And if I continue this so many times, I will have so many distances. And if I want to get out of that for loop and stop in there, I can say continue. Now the for loop is done. The distance, if we go in there, all the distances are calculated. Okay, 600 distances are calculated. So now we have done the major part. The next thing is using a sort function. Sort is not the best idea here, because the bad thing about sort is that it's going to sort everything. But we only need 3 nearest neighbors. So it's not efficient to sort it, because sort does sorting for all the 500 numbers for just finding 3 nearest neighbors. There are better ways, but sort is easier to comprehend, so we will use sort in here. So how do we use sort? Let's help sort in MATLAB. Okay, sort. Sort is, there is a sort function. Simply,
Professor?
Yes.
Would it be possible to, for the sort function, to actually have some kind of conditional statement where it actually only takes into account any of the numbers that are close to the number, to the class, or to the number that you're trying to get close to?
I think no. The reason is because the definition of the sort is sorting array entirely. Okay, so we cannot say sorted, but just sort 3 of them. When we say sort, in its definition, it is going to sort from the smallest to the largest. The use of source is inefficient. Sort itself is very efficient algorithm in here. In MATLAB, it's really quick, but we are not using it in a correct way. So what we say is that instead of sorting, it is better to find the minimum, the first minimum, second minimum, and third minimum. If you want.
Understood.
Okay, so we are not using it in a good way. It's not the problem with the sort itself. But since it is easier to comprehend, and here we don't care about the speed of the code, and the sort in MATLAB is fast enough, the functions in MATLAB that we are seeing, they are written very efficiently. So they are very fast, and sometimes their inefficient use is better than efficient use of our inefficient code.
Right.
Okay.
Yeah, I was just wondering if we could just modify the sort function to meet our needs, but I understand your point, though.
Yeah.
It's fast anyway, so it
It's
doesn't
fast.
matter. To,
Yes. So sort. Okay, sort is good. Let me see how we can get the indices. Okay, here you see x, y, and indices. So there are different ways based on the number, based on the. By the way, welcome, Christopher. So we are in the middle of coding 3NN in MATLAB. So I will explain the code once again. So there are different ways. The basic sort is done this way. Sort, you give the x, and also the mode is ascending and descending. The default, let's see what is the default one. Default is going to be, I think, ascending if we don't give any mode. So let's first sort it. Let's do a test with sort. I have a good function in MATLAB. A equals rand perm, random permutation 10, which is going to create numbers 1 to 10 in random permutation. It's very useful function, especially for if you have a set of data and you want to randomly just rearrange them. You can create rand perm indices and then rearrange your data based on this random indices. So, but here I just want to test my sort function. For sorting, I want to sort A. So I say B equals sort A. Let's see if it is doing ascending or descending. Okay, so it is ascending. And that's what we need, because after sorting, we need to have the first 3 items, correct? But we need more than this, because just sorting will not solve our problem, because after sorting, we want to see which one was the first item to came and became the index number 1. So we need sort this way, B and indices. So this way, it is sorted, and it also says that the index 6 came in to become 1. Then index number 7, correct, came and became number. Let's show A again. This is our A. Let me do one more time. CLC for clearing the command. So A rand perm 10. I multiply it by 10 to make numbers different from the indices. This way it is easier to see what's happening. And then I go to B indices. So you see, so it says this is the sorted version, but the indices that I use for sorting is that I first got the index number 2, which is correct. Index number 2 came and became number 1. Then index number 10 became number 2. Index number 10, correct. Index number 10 was 20. It became second number. Then index number 8, yes, correct. So this way I can get the indices and also get the matrix sorted. So I have a KNN function or KNN gets the training X, training Y. We haven't used the training Y yet. That's the reason it is highlighted. It says that you have a function which is getting a parameter but not using it. So that's a good warning, which is we know why, because we haven't done yet. So here, after the distance is found, let's sort it. Sort distance. So what we do, we simply say that sorted distance and also sorting, not sorted, sorting indices equals, let's use sort on dist. So this function creates a for loop one by one, uses the norm function in MATLAB to find the distance between our test sample with all the training samples. And now sorted dist is found, and actually what we need more is the sorting indices. Now let's run it. Let's run it one more time. So I have this here, code it stops in there. So training X is correct, training Y is the 566 numbers, one column. I want to get from this matrix, only I want to get the row number 1. I want to see what is my classifier's decision on the class of this training test set data. And I want to use KNN for K equals 3, which is, I want to use 3 in it. So I use this one to step in. That's good. I can easily control the code. Class is set to 0 for now. Training feature norms are found. And distance is initialized to make our code faster, because we know that we are going to find 566 distances. So this for loop finds the distances, and then, so let's put 1 in here. So now this is this one, but it's not sorted. As you see, 14, we have 9 in the bottom. So this one will sort it. Let's see, sorted distance, we have some distances that are equal to 0, and sorting indices are this one, sorting indices. So what happens is that I have the sorting indices, which says that in our original data, first number was row number 349, 350, remember this, 349, 350, and 351. Okay, so so what we do is that, let's go to 349, 350, 351. So if we go to TRY, let's see what are those majority indices if you want to find 3 of them. 349. These are my classes. 349, 2, 2, 2. So the majority of the nearest neighbors are from class number 2. So what I need to do here after sorting, I need to, from my training Y, I need to, so let's first create another matrix. So nearest indices are going to be from sorting indices. How many? 1 to 3, but in general here we want to say 1 to k. K can be 5 or 3. Now, you see, before this, k was highlighted as orange. Now that we used it, the MATLAB tells us that yes, this is used now. The only thing that is not used is this feature num yet. So these are the nearest indices. So let's run the code again and see the nearest indices. Nearest indices 349, 350, and 351. Okay, now I can say that nearest classes. Nearest classes is from TRY. Let's see what are those classes from TRY. Let's use the nearest indices to find the nearest classes, and then inside that we will get the majority. Okay. Let's see. So nearest in, this is the dist itself. This is the sorted version of dist. Sorted version. Let's see. We have a question. Sure, yeah, we will have it on YouTube. And we are about to finish. I think in 10 minutes we will be done. Okay, so where is that? So nearest indices and nearest classes, everything is 2. So we should make the decision on the class. So how do we make the decision? So we have only 2 and 4. So what we say is that class 2 numbers is what we can say. Let me write class 2 would be from the nearest classes. We say, is it equal to 2? It will be a logical expression, and we will repeat this for class 4 as well. We have 2 classes, 2 and 4. It's better to write the code in a way that it works with class numbers 0 and 1. But since our original data is based on 2 and 4, then we adjust it. But it's not. It is better to adjust the data instead of writing the code this way. But let's have it this way. So class number 2, class 4, and let's count each of this. Class number 2 would be sum of class 2. These are some zeros and ones, and based on the true numbers, this will be class 4 num. Let's see. Okay, so this is distance. This is the sorted distance, and with sorting the indices. And this is the nearest indices. Nearest classes, everything is 2. So we expect that when we say class 2 is the nearest, is nearest equal to 2 for member by member, it shows yes, 1, 1, 1, which says it is true for all the 3 members. Okay. What about class 4? We see we have 3 zeros, which means it is false. None of the nearest classes are equal to Okay, so yeah, I'm sharing the screen. Let me. Okay, can you see it now? Okay, good. So here is what we did. Class number 2, we check for if nearest classes, which is 222. We want to count each class. So how we count it? We first say, is classes equals to, we will get 3 true false numbers. Everything is true because all these classes are 2. And to find the number of 4s in here, we find equality with 4. We get all zeros in here. By finding the sum of these logical expressions, we say sum of class 2. We will sum all 3 of this, so we will get 3 in here. And when it comes to this class 4, it will give us 0. This way we count it. Now we say if class 2 is greater than class 4 now, then the output class is going to be 2, else it is going to be, class is going to be 4. So we find the majority, and that's it. So now we have the code. Let's now we have a function that gives us the class number. Now let's try this for 10 first training test data numbers. So what we say is that for I equals 1 to, for example, 15, repeat this 10th. Repeat this for test row number I. Let's see what happens. And if we repeat this for 100, not here, here. So now let's do one thing. We have the test data. Let's find the whole test data, the class numbers for the test data. We have 117 test data. So let's create class. First, let's make it zeros. Zeros of 117 and 1 column. So if I run this code, so it will be 117 multiplied by 1, fill them with zeros for initialization. Now let's find all the 117s and put the result of the class in there. And this semicolon at the end, make sure that the result is not printed here so that we have faster code. So the semicolon is not necessary in MATLAB. So now let's find it. Okay, class is found. So let's now compare class with the actual test y. T S Y. This is the class. Let's close everything. This is the class, and this is TSY. So for example, TSY is actually 222 for few first numbers. Up to 69, it is 222. Let's see if we get the same result. It seems that up to 69. But in 70, we have made a mistake. So our classifier has worked well for at least the first 69 data, but in data numbers 70, it had made a mistake because 70, the actual class cancer type is of type 4, but our classifier has decided that it is of type 2. So now let's find the error rate of this classifier. So error, first, number of mistakes, num. First, let's find mistakes. Mistakes is, let's compare our class equals, I believe it will work in one line. We don't need a for loop. TSY. But if needed, we can write a for loop as well. But I think it will work with. Let's see what happens. This one is to separate a block so that I can easily run this block separately by pressing Ctrl Enter. Okay, error. Let's find mistakes. Mistakes is illogical. Okay, it is 1, 1, 1, 1. That's correct. One mistake in here. That's it. It seems that it has made only one mistake. So what our error rate or mistakes num, let's make this one not equal to. Mistakes num is going to be sum of the ones or truths in the mistakes. Sum of mistakes. And error rate is going to be mistakes num divided by test error rate. Test error rate, mistakes num divided by, for now I make it 117, but it's better to write a flexible code that gets this number. Okay, not equal. And let's multiply this one by 100 so that it's based on percentage. Okay, test error rate is this one, 0.85% error rate. Success rate is is 100 minus test error rate. So this classifier works with 99.1453 accuracy, percent accuracy, which means if you want to use this as a classifier, in about 99% of the cases, it will detect the cancer type with the correct decision. So let's see what happens if I make it 5. Is it going to improve my classifier performance if I include more neighbors in our majority vote, or it's better to use 3? So it seems that error rate doesn't change much with increasing 3 to 5. We have the same error rate. Let's make it 7 then. No, sorry. For 5, I need to run this. Okay, it seems that 5, error rate with 5 becomes 0. So 5 works better in this case. 5 works better than the 3 nearest neighbors. Okay, with 3 we had 99% of success rate. With 5 we have 100% success rate. We might get the idea that by increasing 5 to 7 we might get better results. Then let's see. With 7 we get the same. Let's see with 9 nearest neighbors. 9 is bad. So 3 is bad. 5 becomes better. 7 is the same as good as 5, but it doesn't mean that by increasing, by adding more neighbors, you are getting better result. After adding 9 neighbors, using 9 neighbors in your decision process, then it suddenly drops. If you increase it to 11, I think it will drop much more. Let's go to 13. Yeah, so it stops in there. 15. So it drops to 98%. Okay. So that's it for today. I think, yeah, we coded the 3 nearest neighbor in MATLAB. And also we loaded the data from the 2 Excel files, separated TRX, TRY, TSX, TRSY, and use the K nearest neighbor, wrote a function this time which gets the training data, X, training data Y, and also the data that we want to find the class, and also the number of neighbors that we want to use. And then inside that function, we did this, and finally we returned class. And that's it. That's it for today. So any questions?